Go ahead.
Hi, my name is Kitty Caroline Lackey. I am 13 years old and an intermediate 4-H'er. I am also an active member and the president of the Sunny Hop 4-H Club here in Highlands County, and have been in 4-H for the past 3 years. Today, I'm going to show you my science fair project. The title of my project is Does Your Boat Float? The effect of buoyancy and stability with submarines. My question for this project was, how does the buoyancy and stability affect the movement of a submarine? My hypothesis was, I believe that a 500 milliliter model submarine filled with 50% water and 50% air with the stabilizing fin positioned back center, the submarine will move at a level depth and maintain a neutral buoyancy. I had 3 different types of variables for this project. My independent variable is the placement of the stabilizing fin. My dependent variable is the direction of movement. Lastly, my controlled variables for this project is the amount of water in the sub, the increment of inches when I move the stabilizing fin, the same size roller, the same size sub, and the same number of spins on the propeller. Before testing my submarine, I did some background research. I discovered that there are 3 factors acting on a submarine: density, stability, and the buoyant force. Submarines have ballast tanks on either side. If it wants to dive or surface, it changes the amount of water in the ballast tanks, increasing or decreasing the density. If the submarine wants to dive, the ballast tanks fill up with water, increasing the density. If it wants to surface, it expels the water and replaces it with air, decreasing the density. Density is measured on a scale with water at 1. If something sinks, it is more dense, therefore it is greater than 1. But if an object that you put in water floats, that means it's less dense, which means it's 1 or lower into the decimal numbers. If an object floats, it is more dense than that area of fluid that you put it in. Because water is more denser than air, there's more friction when you move with it, which leads us to the next factor: stabilizing fins. Without fins, the submarine will just go completely out of control, because the fins add an extra force of friction when you move through the water. The key to stability is center of gravity. For example, a motorcycle. It is stable when it is not moving, it's tilted upright, because the center of gravity is out of space. When it's tilted just a little bit, it's unstable, because the center of gravity is now not at the base, but at an angle. The last factor is the buoyant force. Instead of acting like gravity, which pulls you down, the buoyant force pulls you up. If you put an object in water, it will continue sinking until the upthrust, also known as the buoyant force, has the same weight as the object. If it's already floating, it has the upthrust already acting on it. Archimedes, an amazing scientist from 287 to 212 BC, discovered the buoyant force while he was taking a bath. He figured out that the upthrust is equal to the weight displaced. If a submarine sinks, it has negative buoyancy. If it floats, it has positive buoyancy. And to maintain a neutral buoyancy, it has to stay right in the middle, 50% water, 50% air, to maintain that neutral zone. The study of density, stability, and buoyancy in fluid is called hydrodynamics. The materials I used for this project is a 2-liter soda bottle, a 500 milliliter water bottle, a razor blade or knife, a drill with a 3 32 inch and 1 16th drill bit, because this larger drill bit will start breaking the plastic in some areas. You also need scissors, a pen or needle, needle nose pliers, a small paper clips. The ones that are really tiny and coated works the best. Otherwise, they will just start to rust. You also need a metric liquid measuring cup, a permanent marker, chopsticks, a stiff ruler, rubber bands. The nice thick small ones work the best to build sufficient tension. You need a waterproof sealants. I use silicone, a bathtub, pool or large container filled with water, a crochet needle, and lastly a lab notebook to keep track of your results. To build the submarine, you cut a flour pattern out of the 2-liter soda bottle like this. Then you drill 2 holes in it with a larger drill bit, one in the center and one slightly off-center. Then you need to make a washer which goes right in the middle, so that way the submarine, when the propeller glides, it will have a nice smooth surface to go on. You use this by cutting out a circle in the middle of the 2-liter soda bottle. Then you take the small water bottle cap and drill another hole inside of that. Then you take a paper clip and straighten one end of it and weave it through first the bottle cap, the washer that you made with the 2-liter soda bottle, and then the propeller. Then you use your needle nose pliers to bend the other end into the off-centered hole. The next thing you can do is drill 2 more holes at the top, this time using the smaller drill bit, or else it'll start breaking the plastic and you'll have to start all over it. Like the propeller, 1 in the center and 1 slightly off center. And to get the paper clip at the other end, you straighten one end of it, already attach the rubber band inside, put one end of the chopsticks through, and weave it through to the end. Once you get it out, you use the needle nose pliers to bend it through the off-centered hole. Then you take a crochet needle to receive the rubber band and attach it to the paper clip in the water bottle. After this is done, it's really important that you make sure you use a waterproof sealant, like silicone. In other words, you need to make sure you have something to take away the gaps, because if you don't, then the water can move freely in and out and it won't be a fair test. Next thing you need to do is mark your submarine. I marked it in different creases in the water bottle for easy measurements. In my lab notebook, I had a piece of paper that told me which measurement was where. I have anywhere from empty to 520 milliliters of water. After you do this, you can fill the submarine with different amounts of water and test it. My hypothesis was 50% water and 50% air inside the submarine, which is right at 260 milliliters of water. Anything lower than this, the submarine started to float. Anything higher than this amount of water, the submarine sunk. So my hypothesis was correct. The next part of the experiment is the stabilizing fins. There's 10 different tests total. There's front center, front right, and then front left. Middle center, middle right, middle left. Back center, which is my hypothesis, back right, and back left. And then finally, the no fin position. When you twist the propeller, you want to make sure you do it the same number of times. I did it 50 times throughout each test. That way it builds sufficient tension. About 20 or 30 times you need to start wounding it like this, or else it'll release. And like I figured out with stabilizing fins, it goes completely out of control, because the stabilizing fins add an extra force of friction while it's moving. Front center and front right and front left, they tilt back a little bit. And then they turn clockwise or counterclockwise. Like I figured out in my stability test, in my background research, if you have an object and the center of gravity is off center, then it will be unstable and return to its original position. To attach the stabilizing fin, you just make an X around a certain area. You need to make sure you have different increment of inches when you're going up and down and side to side. I used 2 inches going up in 3 different places and 1.5 inch going side to side. My hypothesis was back center, which is right here. Back right and back left tilted clockwise or counterclockwise and started to sink. My hypothesis tilted back just a little bit, as you can see. But I was still curious to see what the correct position was. So I tried 1 inch back, and this one completely sunk. So I tried 1/2 inch back, and this gave it a little extra more friction. And this was the correct one, so I was 1/2 inch off on my hypothesis. During my science fair project, I came across many problems, but I persevered and solved each challenge thrown at me. Although my results did not prove my hypothesis because I was 1/2 inch off on the stabilizing fin, I had a lot of fun making this submarine and testing it in the water, and it was really cool seeing the finished product. The best part about doing my science fair project is winning first place at my science fair. Does anybody have any questions?
Did you come up with all this yourself?
No, I got the idea off the internet.
Did you?